Okay, I normally don't record myself, and today I look like a silly goose, but it's fine. Okay, all right, so the first thing I want you to do on your graph is we're going to make our original population. Okay, you can either do this with a dotted line or a straight line, whichever one you like. I like a straight line, so I'm going to do a straight line. So I'm going to start at 0 and red.
And red.
No, and red. So get your pencil, start at 0 and red. We're going to go up and over our colors and down. And we're going to label this our original or OG population. How are you confused? We just drew a line over our colors in the shape of like an upside down U. That's your original population. Okay? All right, now there's 4 different problems. You're only going to mess with your graph for that particular problem you have. So who has problem 1?
Me.
Okay, Baylor, will you read problem 1 to me?
A flock of toots landed in a field and eat 7 red and 8
I'm sorry, Baylor. Some people were being rude while you were talking. Can you start again?
A flock of toots landed in a field and eat 7 red and 8 blue fruit bushes daily.
Okay, so our toot bird said if we had Fruit Loops, we would just take them off. But we don't have Fruit Loops, we have just colors. So what we're gonna do, if I was gonna erase it if I use this whiteboard, but y'all don't have a whiteboard, so I'm gonna show you what I would do. Okay, so they land in the field and they eat 7 red. So I would just draw a line through 7 of my red ones. Whoever has problem 1, only problem 1.
With a pin?
Yeah, or marker, something. They're gone. Okay? If we could erase our colored pencils, we would erase them, but we just need to simulate that they're gone. Okay? And then the blue, they ate 8 blue. So 8 blue. Okay? Simulate to yourself they're gone somehow. Okay? Again, this would look prettier with actual Fruit Loops or with something I could erase, but we're going to work with what we have because that's what we do. There we go. All right, so now you're going to take your pen or pencil and you're going to make the now population. Like after selection happened, what does that graph now look like? So I'm going to do a dotted line for this. So I'm going to go up. I got to go right here because that's where my red population is now. Go over the orange, the yellow, the green. Go down on the blue and go over the purple and down.
And red?
Whatever color you want, Sweet Pea. But tell yourself that that is the new population. That's after selection has occurred. So what was selected against? What do we call the ends of a graph? Do you know? Do you remember from math?
No.
Carly, you said no?
I was just trying to do this.
Somebody turn your phone off. So these are extremes. So the selection was against, it was against this extreme, and this was pretty close to the end, so we could say that it was against this extreme as well. So selection against extreme, and I would write over here, draw an arrow, selection against extreme. Okay, so my number ones, whoever has problem number 1, draw you an arrow to where like the red is and where like the blue was, and his selection was against those areas. Does everybody see that? Because I hear some of you, she's going too fast. I don't understand. So are you good? You sure? Okay. So what kind of selection is that? You have 3 choices. Is it stabilizing, directional, or disruptive? It was in your notes. If this was regular class, I'd make you get out your notes and look. Okay, but since I'm a pushover and this is a college class, go to where it says graph type and write a little number 1 because you had problem number 1. And this is stabilizing selection. Stabilizing selection. Because it is selected against both extremes. So the middle, the average, is going to be favored. So over time, what's going to happen to that average population? They're going to continue to grow and thrive. What's going to happen to the extremes of that population? Yeah. Make sense? Okay. All right, let me reset a minute. So give me a minute. Let me reset. That's for graph number 1.